Let's talk about Mars. You know it, right? Our famous planetary neighbor. It's mysterious, it's fascinating, and of course, it is very, very red. But have you ever actually stopped to ask why? Why is it red? It seems like such a simple question, doesn't it? But the answer? Well, the answer opens up this incredible window into the planet's super dramatic and, get this, watery history. Yeah, you see, the story of Mars's color isn't just some boring chemistry lesson. It's actually the story of a lost world. And it turns out, for decades, we might have been getting that whole story wrong. For the longest time, we thought we had a pretty simple answer for that reddish glow. But some brand new research is coming out, and it's challenging all those old ideas. In fact, it's completely rewriting the book on Mars. So to really get the color, we first have to understand the canvas it's painted on. And let me tell you, Mars is a world of some truly incredible geological extremes, unlike anything we have here on Earth. And it all starts with the atmosphere, or, what's left of it. It is so incredibly thin. We're talking just 0.6% of Earth's pressure at sea level. That's practically nothing. And that tiny little number has some absolutely massive consequences. For one thing, with an atmosphere that thin, there's almost nothing there to hold on to heat. So you get these absolutely wild temperature swings. I mean, look at this. It can go from a pretty pleasant 95 degrees Fahrenheit, shorts weather, all the way down to a bone-chilling -166 in just a matter of hours. This constant thermal shock shapes everything on the surface. And then there's the surface itself, which is, well, it's bizarrely split right down the middle. The northern hemisphere is mostly smooth, flat lowlands, probably paved over by ancient lava flows. But the south, the south is a completely different world. It's high, it's rugged, and it's just been absolutely battered by billions of years of asteroid impacts. It's this huge puzzle that scientists call the Martian dichotomy. And speaking of extremes, you want to talk extremes? Martian geology cooked up the single most colossal mountain we know of anywhere in the solar system, Olympus Mons. Seriously, the scale here is just staggering. Mount Everest doesn't even come close, not even a little. Even Mauna Kea, which is technically taller than Everest if you measure from its base on the ocean floor, is just dwarfed by this thing. Olympus Mons stands at a truly mind-boggling 22 kilometers or nearly 14 miles high. And here's the craziest part. The mountain is so massive and its slopes are so incredibly gentle that if you were standing on its summit right now, you wouldn't even realize it. The slope would just stretch out way beyond horizon. It'd feel like you are on a vast flat plain, not on top of the largest volcano in the entire solar system. How wild is that? So you gotta ask, how on earth did it get so incredibly big? Well, it all comes down to one really key difference between Mars and Earth. See, here on our planet, we have tectonic plates that are constantly moving around. They drift over volcanic hotspots, and that's how you get island chains like Hawaii. But Mars, it doesn't have mobile tectonic plates. Its crust is just stuck. So a single hotspot just poured out iron-rich lava in the exact same spot for eons, building one single gigantic mountain. Okay, but here's the twist in the story. This dry, dusty, volcanic world we see today, it's hiding a secret, a big one. Billions of years ago, Mars was home to the ghost of an ocean. The whole planet went through this incredible transformation. You go back more than 3.5 billion years to what's called the Noacian period, and you're looking at a warmer, wetter Mars. Then things got crazy. The Hesperian period kicks in, and it's this violent era of massive volcanoes and catastrophic floods. And then, quiet. For the last 3 billion years or so, it's been the cold, dry Amazonian period that we know today. And the evidence for this wet past, it's written all over the landscape, like geological fingerprints. We can see these huge channels that were clearly carved by ancient floods, and these winding valley networks that look just like riverbeds you'd find here on Earth. But the real smoking gun? It's the minerals we find in the soil, things like goethite and jarosite. These are minerals that can only form when water is around. And this brings us right back to where we started. Back to that original question, because the secret to why Mars is red? It's hidden right there in its dust. And that dust is a direct relic of that ancient watery past. Okay, so this is where the big scientific debate is right now. The old theory said the red color comes from hematite, which is, basically just common rust, and it can form in a dry environment. But a new theory is pointing to a totally different mineral, ferrihydrite. And this one tells a very, very different story. So, what in the world is ferrihydrite? Well, simply put, it's a type of iron oxide that's packed with water. Here on Earth, you find it where volcanic rocks are breaking down in cool water. Think of it like a direct chemical fingerprint of a very specific, water-filled environment. And this new analysis, it suggests that this mineral is everywhere in the Martian dust. It was created billions of years ago, back when the planet was wet and all that water was reacting with the iron-rich volcanic rock. So, get this. This means Mars isn't red because it just sort of rusted dry. It's red because its watery past is permanently stained into its very soil. I mean, this new theory could completely reframe how we think about Mars. And the proof? Well, the proof might already be sitting on Mars right now with the Perseverance rover. It's collecting all these rock and soil samples to eventually bring back to Earth. So the big question is, will those samples finally, once and for all, solve the mystery of the red planet?